Hello, hello. Welcome to today's webinar, this week's webinar. Octopus Deploy and Azure pipelines integrate really well together for a completely automated DevOps environment. And there is lots of documentation that shows how to deploy applications in this environment with these tools. But often the examples don't include a complex SQL Server database environment. And there's some specific things that need to be a part of your uh, DevOps pipeline configuration in order to include a relational database on SQL Server with your application. So I'm really excited that you're here with me today. We have had a tremendous response to this topic, and I'm glad at the crowd of people that are here with us today. It's going to be fun. Um, I am Jeffrey Palermo, the Chief Architect of ClearMeasure, and ClearMeasure is a software architecture company that empowers our clients' development teams to be self-sufficient, moving fast, delivering quality, and running your systems with confidence. And so we're here to help you deliver world-class results and get better and do the things that you want to do and help your project succeed and get down the road. So we're gonna move into our webinar topic, a few logistics. There is a Q&A window where you can ask questions during the webinar. I'm pretty good about answering questions in line instead of just waiting until the end, but I'll make the commitment to you that I won't close the webinar without having all of the questions answered. And there's going to be some different resources and downloads that are provided, or opportunities to request those in the chat window. You can request those by going to the chat window and making sure that you have that and you're looking for that in Zoom. And also for being here at this webinar, we are recording this, and you will get a copy of the recording. And if any of your colleagues didn't get a chance to come, you are free to share that recording with them. So let's dive in. Now we're going to go through and talk about why this is important, what the challenges are, what it looks like, and then we're going to lay out a roadmap for integrating your database in with your automated deployment. So we're going to dive into all the settings that need to be there in Azure pipelines, as well as in Octopus Deploy, how to tie those and stitch those together, um, and then um, and then move on to next steps. So when it comes to Octopus Deploy, we do a ton of implementation, and it is the world class automated deployment tool. It was one of the first on the .NET platform for sure, that really made it easy. And while there's a few more options on the marketplace today, it continues to be the most comprehensive, and we do a lot of that. And so um, uh, when it comes to the patterns for integrating Octopus Deploy with build servers, whether it be Azure pipelines or TeamCity or Jenkins, we've worked with Octopus Deploy to kind of establish how those should be. I've also done some past joint webinars with Paul Stovall, who's the CEO and founder of Octopus Deploy. You can find those recordings on the ClearMeasure YouTube channel, youtube.com/ClearMeasure. If you want to go back, we've done some advanced DevOps Q&A that included a few database topics as well. And so, but if you need any Octopus Deploy help at all, we're here for you, and we're real close partners with them. Now, here's the problem that we're dealing with. We have uh, we have a complex SQL Server database in our architecture environment, and sometimes it causes us to cry. We want it to be high speed, high quality for any database change we make, and we want to move from a slow cadence to a fast cadence. Okay, and I mean, everyone we talk to, they always want that. Now, there's some problems involved, but when we look at them, we may just scratch the surface. So, you know, as a software leader, if you're in that role, you're responsible for the fitness of the software and the software process, and you're accountable for the stability of the environments as well. And you're the one that who must equip your development teams with the process for developing the software systems that includes a SQL Server database. And so I'm not going to ask for raised hands because I can see everyone's hand raised already. Who still does manual database deployments, or if you have database changes that are scripted out, maybe those are still manually executed, and it's not a hands-off, fully automated, no-touch environment. What it should be is is we commit to the Git repository. There's a pull request. It goes into master, or whatever branching strategy you're using. But when that code makes it to your master branch, it is just hands off. And the integration build will build and package. I'll go through those steps. And then your test automation environment, which comes first, should be automatically deployed because that environment's not for humans anyway. But you automatically deploy to the environment, so you know that the change that you just made didn't totally break your database or didn't break the application that was depending on that column in the database being a certain length. Okay, and we see a lot of cases software configuration management, or SCM, is not being applied to the database like it is maybe to a web application deployed component, or a offline job, or an Azure function, or a Windows service. And oftentimes as well, systems that have been around a long time have a web of dependencies across the enterprise architecture that doesn't make sense. For example, in a DevOps world, it forces us to make the architectural decisions of what application owns this database. It forces us to make that decision. And if it's unclear, if multiple applications have a connection string to a particular database, and you say, well, that application doesn't own that database, and that application doesn't own that database. So what Git repository do I put this database schema in? What pipeline do I put this database in? Because I have 10 applications that all depend on this database and all have a connection to this database. Well, there's going to be some messiness of the history that you're going to have to move through. And in some cases, we have seen where we're understanding the actual architecture versus the maybe aspirational architecture. The aspirational architecture is for every application to own its data store, and then for it to have inbound and outbound data streams, okay? As opposed to just having one database in the center with a lot of applications that all just have connection strings to it, because then you have a big global data dependency. Now I can see through the screen some of you shaking your head because that's maybe what you have. And we've seen that a number of times. The DevOps answer to that, and I know I'm digressing a little bit, the DevOps answer to that is to realize architecturally that you have a massive database that kind of has been created as an application of its own, or a standalone system of its own, and it can't architecturally belong to any other application, because then it just doesn't fit. And so if the reality in our architecture is that this database needs to be a standalone application, essentially then it's a peer to all the others, well, then we give that database its own DevOps environment, its own Git repository, its own pipeline, its own integration build, its own test automation environment, its own manual test environment, its own release candidate packaging. And then the schema of that database can then be packaged up in a NuGet package and then shared as a library dependency, just like any other NuGet package, shared with the other applications. They can bring that in, then they can execute that schema. They can create a copy or a read-only schema for testing purposes, and then these other applications that have connection strings to it and depend on the schema can use it and do what they need to. But that is a common solution. So let's move on through. All right, so here is our industry's model via Wikipedia for DevOps, and I don't like it. It maintains two different teams and suggests some of these smooth handoffs between them. And so we prefer untwisting the figure eight to really combine and not have dev and ops. Oh, but then what about QA? What about security? Now you have all these circles running around. Instead, we need one cycle and a truly cross-functional team. And so this is what we need with the, and you notice the automated DevOps pipeline is in the middle. And so this view is integrated and shows a single cycle of stages around the outside, from planning all the way through learning, by observing the impact of the change that we're making and how people are using it. And the center is the automated pipeline. It's the foundation or the axle around which our cycle spins. And it's the assembly line, the central pipeline through which ideas flow out to be working software. But it's only the start. And because the scenario for web applications is dirt simple, you've seen it everywhere. If you've seen a quick start, you've seen a DevOps pipeline example that's pretty much only a web application. Well, most of the time, the only thing that it takes for a web application to be deployed is copying some files. So it's hardly a real world situation. But none of these samples include your very important SQL Server database. And so today you're going to see how to equip your team with a complete DevOps capability that includes the SQL Server database. And now we have a complete model for what we call DevOps-centered software engineering here at ClearMeasure, and it's enabled by the automated DevOps pipeline, which must include your database and every other component of your software system. But there are 5 other layers of capability that must be accounted for. We've talked about this in depth in other webinars, but I wanted to touch on them because DevOps is all about identifying the capabilities that you need, and then defining a strategy for it, executing it with discipline, and then measuring to make sure that you have the right strategy. So we're not going to dive in deeply about that, but let's get into the databases. Now, when it comes to deploying databases, there's some fundamentally differences in a database than a web application or a Windows service or anything else. And here's a funny and real social media post by a gentleman named Michael Richardson, and in the real world, there are 0% of applications that have no data stores, no databases. But in articles on deployment patterns, 100% of them have no database. And that's probably why you came to this webinar, because it's such a big need, because it's everywhere. And then we think, why do all the quick starts and why do all the documentations just ignore it? Now, here are some things that make it fundamentally different. So in the cloud world, the language has been distilled down to compute and storage, and then networking and things like that. And so there are compute components which don't have any state, but move state through or move data through. They don't inherently own any persistent state. Even a cache would be a cache service, and it would be in the storage category. So a web application, an Azure function, or even if you're on a Windows environment, a Windows service, an IIS application, those are just compute components. They don't have any state. They can be destroyed and put back easily. And that's why all the simple, trivial DevOps pipelines you find on YouTube and elsewhere have a website and no database, because that's the easy part. The storage components, they have to preserve data for years, whether it's a blob table storage, a directory structure of files on disk, or any type of database, relational document database, data warehouse. Your deployment must cope with data that has probably been there since before the word DevOps was coined in 2010. And if you have data from before 2010, that's definitely true. So when it comes to software, the data is more likely to be the company asset rather than the code that operates on the data. Some of that data probably existed many years ago in a file cabinet of some sort before the company went through digitization. And at some point, the current applications will be replaced by different ones, but the data will live on and continue to grow and change. Now, test environments. These are easier to manage by dropping and recreating databases. You can do that. Now, you do it much less frequently in a UAT or a staging environment, and you never do it in production environments. The data is always there. And so there's a few factors that are the same and different when designing the right deployment process. And we're going to look at these throughout this webinar and dive into each piece. So let's look at the different types of data or types of state that we need to manage when we're deploying a database across different environments. I'm summarizing categories of production and pre-production. And I'm kind of lumping in the management of a not production environment when we talk about this. So as we go through here, there is, in a software system, there is the schema structure, and then there is schema data. And the schema, or the structure of the database, that is owned by the software system or software application. It is owned by the software system, and it should be exactly the same in every environment. The environment cannot modify that, okay? Now, some data is architecturally part of your schema, and it should be the same across the environment. For example, if you have some standard lists that populate drop-down boxes, such as common names, prefixes, Mr., Mrs., etc., these are the same in exactly every environment. It doesn't change in production. Now, some data is configuration and belongs to the environment itself. Architecturally, it belongs to the environment itself. Just like some configuration is stored in XML or JSON files and settings are poked into it during deployment, some of this configuration is stored as records in a database. And you could probably imagine, hey, well, that row of data in the database, that could be a config file, I guess, if we want, but it could be in a database as well. That's configuration data. Some systems have settings that could be either one, but they reside in that database table. So in that case, that table is environment-specific configuration. Now, some data also is administrative data, and without it, the software system doesn't do much. An example of this is a user, a customer, or account records. With none of these, no user would be able to log in and use any of the software features. What's very common is for there to be an admin type user where the admin has to log in even to create more users. And if you don't have that admin user account in that database table, if you literally have a database with 0 rows in it, the application can do absolutely nothing. That's administrative data. And the rest of the data is what you think of as user data. That's the normal data, consistently growing, consistently changing as people use the system, okay? So when you're putting together your DevOps environment, you need to categorize this data because it goes in different places and it comes into the environment from different places, all right? You can't, and in production, even though this data is there, you're not just gonna drop it and recreate it. So when the configuration data or the administrative data changes, that needs to be a part of the deployment, okay? You're not going to have part of a deployment be user data. That is gonna be created by users, and if you're gonna modify it, it's gonna be a data load of some sort outside of your normal deployment. Okay, so where Octopus Deploy comes in, is it houses some of this data. So the deployment pipeline itself is going to house the settings that make up the configuration data in your Octopus Deploy pipeline variables. Now, if your company, we'll talk about this later, but if you're pairing Octopus Deploy with a build server, you can choose for a variable value to be housed in Octopus Deploy variables or in your build server variables. When a build server calls Octopus, you have the option of passing any number of variables you need into Octopus. And there's a checkbox in Octopus called prompt for value, and that can be on the user interface, or it can be conceptually prompting the command line for that variable and receive it from the build server. And so it's common when pairing Octopus with pipelines or with TeamCity that you're going to have some of the variables defined in the build server variables. And when the build server calls Octopus, we're going to flow those variables through, and Octopus is going to use them and poke them into config files or a database insert script, whatever it happens to be. Okay, so let's move forward. Now, here is this will be your default structure for the development view of your application's architecture. The development view is your pipeline. And most of you on this webinar are architects or lead developers, leaders in your teams of some sort. And you understand strategy. If you pick the wrong one, it doesn't matter how good you execute the wrong strategy or the wrong architecture, because architecture is part of strategy. You won't get the desired result. So when it comes to important technical decisions or the structure of the DevOps environment, architecture is that strategy. So a pipeline has to support the scenarios that you see in the box on the bottom left. And by the way, this is the top third of a architectural poster that we have, and I'll show bits of it here, but it's too big to show on one slide. I want you to have that. So if you don't already have that, if you haven't attended a previous webinar, actually this is a customized version. So I want to send this to you, and just go in the chat and request a copy of this architectural poster. All else fails, send me an email. I'll get you hooked up. Okay. Now, look at the bottom left. These are the scenarios that your pipeline must support. And we like to pack in a whole lot of capabilities. But if you don't have at least these are the minimum bar for a DevOps pipeline. If you don't have these, then you're going to have obvious gaps. Now, notice that we don't mention anything about the database here, but we also don't mention anything about a web application. We don't mention Windows services. We don't mention Azure Functions. We don't mention any application component type or specific infrastructure. When you're looking to create a pipeline for an application, the pipeline must support everything that makes that application work, everything within the application box on your enterprise architecture. And I'll come back to that later. I'm going to show you the architecture for an application that consists of a web application and a SQL Server database, just to keep it simple so that you can see how this all fits together. And then we're going to discuss how to put that into play with Azure Pipelines and Octopus Deploy. Now, let me go to the next thing and zoom in here. There we go. Okay, so we are going to zoom in to the part before the deployment and go through that in detail. So I'm not going to read all these words to you, but I want you to have this poster so you can see all this detail for all the things that need to go where. We're pretty prescriptive about it. And we start with how to store the source in your version control system. Every part of the application, which remind you, includes the database. So your database migration scripts need to be in your Git repository. If your system uses microservices or any segmentation pattern, then you'll have multiple Git repositories because each microservice will have its own database. Let me take an aside here. I have seen some implemented systems that have been labeled microservices that are like a dozen different processes running around, each with their own Git repository, but they all have the connection string back to the same database. That's not microservices. That is just a spread out application. That is a multi-process application because you've retained a central global dependency, which is your database. If you're going to segment something out to a service, the first attribute of that service is that it is autonomous, meaning it has to own the state upon which its main function operates. It's going to receive data from outside. It's going to send data to others through synchronous and asynchronous messaging, but for the data that it owns, it really has to own it architecturally, and it has to have its own database. So if you're segmenting an existing application into smaller services, and if you're talking about microservices, which so many people in the industry are lamenting the word microservices because it gives the false impression that all of these services have to be tiny, which any software service that is worth deploying is going to be significant, okay? But if you're going to segment out into multiple services, you need to segment out whatever data stores you have as well, so you give from an ownership perspective, you give that data store to the service. Now, I'll call it just each one of these an application. There's one application per Git repository. That's a DevOps rule. If you break it, your life's going to be hard. That's because all of the products on the market are tested, and they kind of have that as an architectural assumption. They work best in that scenario. You'll be constantly adapting to the products if you break that rule. Now, from a relationship perspective, the architectural relationships, one team can develop one or many Git repositories, but one Git repository can only hold one application along with its components, and one Git repository should be built by one continuous integration build. So if you have one Git repository, you have one DevOps pipeline, one for one, okay? Don't have a separate build, for example, for feature branches and have a separate build for your master branch. You want one integration build that operates on that Git repository, and you have a synchronous flow through your pipeline. The integration build also will produce a deployment package for each application component in that single application. Now, remember, an application, we're going to talk most about just a web application and a SQL Server database, but you'll also have an offline job, a Windows service, or an Azure function. And think of a Visual Studio solution. Everything in that application is going to be in that Visual Studio solution, even though it may result in multiple deployed processes. It's versioned together. It's one thing. It operates together. It gets deployed together. It's not like you're going to cherry pick changing the web application and deploy it independently. Now, if you're not doing DevOps automation and you're doing a manual deployment, I understand that you've done that in the past because, oh, it was just a spelling mistake, or it was a UI only change. That's fine. But when you get your automated DevOps pipeline in place, you're going to deploy everything regardless of what the change was, not because it literally has to be that way in order to work, but because it's easier. But because it's totally automated, you would have to do manual intervention to cherry pick, and it's just more work. So you just deploy all three, and it's easy and it's fast, and there's even patterns for absolute zero downtime transition. So when you go down the road, you're not even worried about downtime. Okay, so let's talk about how the integration build for a database has to integrate with the Git repository. With an application component, we have some files that need to be copied and some configuration that just needs to be poked in order to run integration tests in our build, but not so with the database. We have to create a build level version of the database schema in order to run integration tests. And also, our integration test is going to be running our private build script. Okay, if you go way back to 2006, when the continuous integration book was published, the umbrella of continuous integration was defined, and it started with the private build in the commit stage, and then ended with validation of a deployment. Okay, so the purpose of continuous integration is for multiple people to be changing the code of the application, and hence changing the schema of the database. They're all changing things at the same time, and we want to integrate the changes from multiple people in the team continuously. So the main question that continuous integration answers for us is, did the change that just come in destabilize our application? And we want that answer to be no. If the answer is yes, we need to find out right away, roll back, get it back to stable, and let the developer who made that misstep, let them try again. And that includes the application components and your SQL Server database. And so if we're just stretching a field to be longer, that's going to have some UI changes and it's going to have some database changes. So we need to do that together. But if we're going to continuously integrate, then to answer that question of, did I destabilize the system or is the system still stable? We can't get that answer until we deploy the application, start it up, and at least run a few smoke tests, if not our full system test suite. Doing a automatically triggered compile is not continuous integration. And it's off topic for this webinar, but I do see people saying, we have continuous integration in place, or they'll say, we have CI in place, but we don't have CD in place yet. We have CI in place. And then oftentimes we'll look at it, and it is a automatically triggered compile. Basically, it's an automatically triggered build, and the build contains a compilation of C# into assemblies. That is a necessary piece of continuous integration, but it is not continuous integration. They're missing the private build up front so that at the developer workstation, we know that our application is still stable, and they're missing their deployment to a test automation environment to know that they didn't just completely hose the application. Continuous integration without a deployment doesn't really even tell us much. Okay, so this diagram, it kind of outlines the different steps. This is the first mention of tools for database migrations. Redgate is probably the best commercial tool for database migrations. You'll want to look at SQL Change Automation, or SCA. There are 3 popular open source tools for database migrations as well. From order of popularity, the most popular is DBUp. The second most popular is Roundhouse, although .NET Core support is, I think, still in the works. And then the third is AliSQL, which is purely just command line. And all of them use the same premise that there is a directory with sequenced files, with numbered SQL files. And every SQL file is a change, is an alter statement, okay? And so the first SQL file is probably gonna be create a table. And then as you go down, you're gonna have a database SQL file that is alter the table, add a column, or you're gonna maybe stretch a column or whatnot. And there's plenty of compare tools that will generate alter statements for you. You don't have to don't handcraft them. It's gonna be more surface area for a bug. Just let the tool do it and then examine it to make sure that's what you meant. Okay, so let's move on. Now, we need to map and package our application components to different packages. Our ASP.NET project, that's going to go into a package for the user interface, an offline job. That's going to have its own package. All these packages are NuGet format. They're going to be stored in Azure artifacts. Your acceptance tests, test suite, your in-unit test suite, that's going to be packaged up as well. You notice that all of these are going to have version numbers, and your database is going to be packaged independently. So you're going to have a release candidate set that is, in this case, 3.4.352, and you're going to have 4 of these packages. And together, they represent a release candidate, okay? All right, so let's dive into the deployment aspect. We are going to orchestrate Azure pipelines on top of Octopus Deploy. This is important because we don't just want to hand off to Octopus Deploy and then have to promote in a different tool. There's 2 main reasons. The first main reason is that that for anyone who has an approval step, it's pretty common for there to be an approval button or a gated deployment to production. And if you're going to have that approval step, if you hand off, then you're going to need to have stakeholders have access to your Octopus Deploy server. It's a lot better configuration to have the Octopus Deploy server locked down, have only a few people have access to it, and then just be able to handle the approval straight from pipelines, which is going to integrate seamlessly with your Microsoft 365, your Active Directory. All your stakeholder accounts can be in there and managed in one place. The second is because you're doing DevOps and you're running tests, okay? So Octopus Deploy is not a build server, and they're not going to become a build server because that's a whole other world. So you pair a build server with Octopus Deploy and you orchestrate them together. Your build server runs tests. Your Octopus Deploy server deploys it provisions environments, it deploys application components, and it manages, operates, and supports, monitors environments that run custom software, okay? And over this past year, the worker roles and runbooks have been phenomenal new features in Octopus Deploy to help you really manage the environments in a modern way, much better than traditional IT tools that were really designed for on-premise data centers. And so we're going to go into how to orchestrate these, but let me just walk you through one scenario, and I'll use my mouse to point. The integration build completes. It triggers an automatic deployment to our test automation environment. We call it the TDD environment for test-driven development. You're going to have a minimum of 3 environments in a pipeline, 1 of each type. You have your production environment, which everybody knows about. You need at least 1 of those. You need a manual test environment, at least 1 of those. Common names of manual test environments are dev, QA, sit, dip, staging, UAT. There's all kinds of names, but they're all the same type. They're a manual test environment. Someone has to do something with a human has to do something and then either give a thumbs up or report a problem. That's a manual test environment. In a DevOps world, you need a test automation environment. No people go on this test automation environment. It's automatically triggered, automatically provisioned, hopefully if you're in the cloud. And even if you're on a Windows Server environment, a Windows Server can handle many parallel databases and many parallel websites and many parallel Windows services. If you have global names, all you have to do is tokenize and push the version number into the name of a Windows service. And now you can have an infinite number of these services side by side. And then architecturally, of course, it'll force you to deal with any global dependencies you have there. But you need a test automation environment. So we're going to kick that off. It is going to immediately integrate with Octopus Deploy and say, hey, please deploy version X, version 3.4, point whatever. And then Octopus Deploy is going to configure the environment. It's going to deploy, and then it's going to be done. Then control is going to go back to Azure Pipelines, because now that'll be finished. And now Azure Pipelines can run your full system test suite, whether it be Selenium or Cucumber or whatever it happens to be, your test suite that must operate on a fully deployed instance of your application. And so those tests are going to run, and then you record it. Okay. So that's important. Now we see some differences in the steps for each of these environments. I'm not going to go through them each, but it's really important that you orchestrate it here. Also, the comprehensive logs of not only the deployment, but also the test suite and any validations are going to be stored in Azure Pipelines. They're going to be stored in Octopus as well, but Octopus is going to stream those logs over to your build server, even if it was TeamCity, and now you have one place for everything that happens. An Azure pipeline is a pipeline figuratively of water. Just like you don't want tidal waves and droughts, you want a smooth flow. Every step of the way, everything you do is a filter, and it filters out impurities in the water so that by the time the water gets to the customer, it is tasty and pure and clean, crystal clear water. And so every step along the way, we need to make sure that we're not just moving the water down the pipeline, but that we have a filter, okay? So let's look at the manual test environment and the production environment. Every single one of these needs to deploy and then run a test suite before we declare that it was a good deployment. Because if we don't at least pull up the main screen and do at least a smoke test, we don't actually know that the application is ready to go. And if we don't have it in our automated pipeline, then it's going to have to be a manual step that somebody does. And the point of this is to take every manual step that we do and automate it. Okay. So every step of the way, you need a test suite, even if that test suite is a single task of go get that URL and make sure it doesn't blow up. That's still a test. That's still figuratively a filter in your pipeline that has the ability to catch any impurities that may be going down in the water. Okay. So when it comes to the environments, Octopus Deploy is going to be configured to do different things. It's going to grab the database NuGet package, which is going to include all of those SQL scripts and your database migration tool. And for the test automation environment, the TDD environment, it's going to provision the database, and it's going to do the schema migration, and it's going to push in a user data set that is meant for the test suite, okay? For UAT, it's not gonna provision the database. It's going to run new schema changes, in other words, schema changes that haven't been run so far, and then it's gonna have an on-demand or variable triggered reloading of the data. And then production, all we're gonna do is do any database schema changes. So every single time that we go to production, there's we're going to have to check, hey, was this schema change run already on this production database server or not? And if not, it's going to run it. Okay. All right. So we talked about the integration strategy of orchestrating pipelines over Octopus Deploy as opposed to doing the fire and forget. Now I want to talk about a caveat. There are some advanced Octopus Deploy scenarios that don't have any parallel in Azure pipelines. For instance, the multi-tenant capabilities and then channels in Octopus Deploy. They don't have any representation in pipelines, so there will be some additional advanced scenarios that will be Octopus only. But for the normal day-to-day steady flow, you want that orchestrated, and that'll work really well. But this is what your Azure pipelines view is going to look like in the visual designer. We're going to have the integration build, then we have our TDD environment, UAT environment, and prod. This is the shortest and smallest you will have. You have a test automation environment, you have a manual test environment, and you have a production environment, and they are in sequence. Okay. I'm not going to, there's a lot of details in here, but we're focused on databases and Octopus Deploy right now. So there's a lot to go into. This is what the pipelines view is going to look like. And YAML came out last May. And so in a couple months, it'll be right on a year. They're still working on the designer experience for YAML and debugging, but a lot of people have adopted already. Same parallel. Here's the structure. In our TDD environment, we immediately tell Octopus Deploy, hey, deploy version such and such. And we want to make sure that we pass through command line variables where the variable value is owned by pipelines, so Octopus Deploy can receive that variable. Important here would be the connection string and database name and some things like that. You can have any number of variables, my variable, Jeffrey, that just to illustrate, you can pass whatever you want, okay? Then after it is deployed and Octopus Deploy says, I'm done, then we're gonna come back and we are going to download the package for our full system tests from Azure Artifacts. And we're going to poke in the connection string, what URL our Selenium tests are going towards, and then we're going to run the test suite, okay? That's why we need to tell Octopus Deploy to deploy and then receive control back so that we can run the test suite. And that pattern continues on with UAT in production, even though the test suite may just be calling a single URL and saying, hey, does your built-in health check still work? Okay, we need to do that. All right, now there are two ways to ask Octopus Deploy to deploy something. You can call the promote integration, or you can call the deploy. When integrating a build server with Octopus Deploy, don't use promote. Promote is going to look at what version is in the previous environment based on the Octopus lifecycle, and then is going to determine what next version is there available, and then is going to make the decision to essentially promote from a prior environment on to the next one. Because we have that logic in pipelines, we don't, we'll introduce bugs if we duplicate it because they're not gonna always agree. So we wanna use deploy. Deploy gives us a text box where we can tell it, deploy exactly version such and such, and it just does it. So that's what we wanna do, okay? All right, next, I talked about this prompt for value. This checkbox is what you need to check if we want to receive the variable from our build server, okay? Really important. Now, this is what your Octopus Deploy project is gonna look like. The Octopus Deploy process, if yours scrolls and scrolls, then it's too complicated. It's very, very rare in a Octopus Deploy process that we actually put in a PowerShell script step, because every one of these package deployments can include execution of PowerShell. And so we don't want to make this a really long procedural program that ends up needing to be debugged because we don't know what's going on. By the way, when you're first getting this in place, here's a pro tip. Install the Tentacle software to your own workstation and attach your own workstation to your Octopus Deploy server so that when you're executing this and running it, you can actually see what's happening locally. You can rerun those PowerShell scripts locally, whatever's part of your deployment, and you'll have a much faster cycle time of change run for the first time you're getting an automated deployment going. If you are only running on a target server, now you're in remote desktop, or you're trying to figure out it's happening over there, what context, and it's a lot more confusing. And so that's a pro tip. Make your own workstation a tentacle, attach it as an environment, and then get it working. You'll see, oh, wait a minute. This variable is not available for some reason. It's coming up blank. You'll be able to debug so much faster. And then once it's working, then have it run against another target environment. So human approval, we've got these disabled here because when you're integrating with pipelines, you want to have that approval in pipelines and not Octopus. Application insights, annotating the release, that can happen in Octopus or that can happen in pipelines. It's your choice. And we sometimes put it in Octopus Deploy because if you're using tenants or channels or one of those advanced features and you don't have it in Octopus and you do a release, well, now you haven't annotated it. Now, could you put it in both places? Yeah, it's not really going to be any harm in there. It'll be a duplicate, but that's actually no big deal if you prefer that. Now, in an application with a database and a web application, you're going to have exactly 2 of these deployment steps. We're going to do the database first, and then we're going to do the UI, which is an IIS step. That's it. Those are the only 2 we need. The logic is inside here, okay? Now, before I dive into it, I want to show you what our packages are going to look like. Now, on the left, we have a view of our NuGet server, which is an Azure Artifacts. Notice Onion DevOps Architecture .database, okay? That's our NuGet package. On the right is the contents of that package. Inside this scripts folder is just a list of SQL files. And the first one's going to contain a create table. By the way, none of these SQL files have a use statement. None of these SQL files have any knowledge of the name of the database they're running against. If your scripts have a use statement where you're telling it what database to go against, you need to expunge that from your scripts because you want these scripts to be able to run on any named database. Locally, we're going to be creating a local developer level database on my workstation through the private build process. On our test automation environment, there's going to be a named database. The database name is going to be different with every build. The best practice, one of the best practices, is to put something that changes every time. A version number is a good option. Put that in there, and that is going to expunge any notion of the database name being a global dependency. And that also enables us to do branch level DevOps pipelines, because even from my branch, I can deploy to the test automation environment and not have to stomp over the master branches. Now, I'll call your attention to the bottom. Update Azure SQL.ps1. This is an arbitrary PowerShell file. Now, if you are Octopus only, then you can use a post-deploy.ps1 file. If you have pre-deploy.ps1 or deploy.ps1 or post-deploy.ps1, those are file names that are recognized by Octopus, and those will be automatically executed. But I tend to name it specifically and then tell Octopus exactly what I want it to do, because we work with so many different build servers that we try not to have any infrastructure related knowledge stored in the Git source control. And so if I have a convention in my Git source control that only works with Octopus Deploy, then that's a little bit tighter dependency than I want. In the same way, let me show you what is in this update Azure SQL on the next slide. Now, notice that I am grabbing variables from environment variables. Whether it's scripts that run that are kicked off from the build server or a deployment server, environment variables are your common thread. Environment variables are going to allow you to move data around, because all these different products do variables in a slightly different way. But if you're going to be storing this script in source control, you want it to be, you want it to not have any even conceptual dependencies from these products. And so we grab the values from environment variables rather than assuming that this script is running in an Octopus context and pulling them from Octopus variables. And so then we're going to use our database migration tool, AliSQL, and execute that command line, which essentially is going to migrate our database, either create it if it's not there, or upgrade it and run the scripts that haven't run. Now, our variables, these variables, these are pieces of data. You have to decide who owns it and intentionally structure your variables. This is an architecture level thing. Don't just leave it to implementation to, oh, add another variable. You need to think about the structure of it, and you need to remove duplicates. Your applications have duplicate settings, duplicate values all over the place. And this is where you decide, okay, here's a value. Maybe this value gets pushed to 5 different places, but this is where you make sure that you're not duplicating that value 5 different times. So think about that intentionally, okay? All right, and by the way, make heavy use of tokenizing as you create additional values, like connection string. As opposed to duplicating database server, we have database server tokenized in here, and we have a default value here that we can change. All right, your database migration package step. It's essentially going to be stock. We're just going to grab the package, explode it, run a command. That's it. We point it to the database server, which, by the way, it's very normal for the tentacle not to be deployed to the actual database cluster, but to have a server that is designated as your database management server, okay? That database management server is your database server. And that database management server will have connectivity, firewall connectivity, to be able to contact your database cluster and make the changes. So when we deploy, the tentacle is actually on a database management server, because if, and this is true in a lot of cases, if you have a database cluster, because now if you have a single node database, and you have the tentacle on that server itself, that works just fine. But production database clusters or Azure SQL, it's much more common. So you just want to have a database management server. Now, if you're using Azure Platform as a Service only, well, then this will be different. Let me dive into the one feature that we have, which is a custom deployment script. That's the one configuration that we have. And what are we doing here? We are converting Octopus deploy variables to environment variables. We're just that little shim, and then just a few write hosts for demonstration purposes. We do a lot of training, and so we add things for training purposes. And then we're calling update azure.sql. Now we have the /. That is because this script runs as a working directory of the root of wherever your NuGet package was unzipped. And so armed with all of those files that are inside that NuGet package, we're going to call update azure sql.ps1. All right. Branching, I'm not going to go a lot into branching, but you want to enable this DevOps flow on every branch, not just your master branch, all the way to your test automation environment so that you can run your full system tests. Now, we have so many examples and so many clients that have had tremendous benefit from this, and there's plenty of success stories on our website, on our YouTube channel. And when equipped with a complete professional work environment, a complete DevOps pipeline, and a strategically determined process, we see teams become truly world-class. We hear of teams moving fast at maybe Google or Netflix or Microsoft, but any of your teams, I'm here to tell you, any of your teams can be just as effective when equipped properly. We want you to be self-sufficient, but we do a lot of guiding as well, where we come alongside you to get you through. And so whether it's project definition or architecture or a DevOps assessment or inspection or a modernization roadmap, our goal is to come alongside you as essentially a virtual chief architect and guide your team and get you through what you need to get through. We do tons of DevOps designs, DevOps strategy, DevOps implementation, and as well as performance enhancements, whatever your team needs in order to move fast, deliver quality, and run with confidence. And I mentioned at the beginning, or it was on the slide at the beginning, we have a spring break promotion, a free offer for a 30-point Octopus Deploy pipeline inspection for your pipeline. Pick any of your applications and we'll inspect it. We'll give you a comprehensive report. Everything that we find in that 30-point inspection will come with a specific recommendation to remediate that and improve that area of your pipeline. So go ahead and just contact us to take advantage of that free 30-point Octopus Deploy pipeline inspection, and we'll get that to you. So this has been a ton of information. I think I was able to work in the premise of the questions as we were going through. I don't see any additional questions that have come through, but if any comes just in the meantime, I'll answer it. My contact information is right here on the screen, and feel free to call, email. You can find me on Twitter at Jeffrey Palermo. We are going to get you the correct version of the DevOps pipeline, the DevOps architecture pipeline that we mentioned. So just make sure that you've requested it so that we have your name so that we can get that to you. And with anything else, any questions, send me an email. I love it when people reach out because I love seeing development teams succeed at moving fast and delivering fantastic results. And when equipped properly, every team succeeds. It's just amazing. So we just need to figure out, hey, how do we need to equip you? All right. Well, thank you very much. I think we got all the questions in. Hope you have a great day. And hey, until next time, keep shipping.